IP addresses are expensive to buy or lease. To be cost effective, a business must use every asset to its full potential, including an IP address. Classful IP addressing gave us a one-size-fits-all mentality. This led to a lot of wasted addresses in smaller networks. Variable length subnet masking, or VLSM, is commonly referred to as classless interdomain routing or classless IP addressing. Classless addressing schemes waste less IP addresses than classful addressing schemes. Classful addressing has been proven to waste IP addresses. VLSM allows network administrators to divide an IP address space into subnets of different sizes, also known as discontiguous networks, unlike simple same-size subnetting or contiguous networks. Quite simply, in a way, it means subnetting a subnet. It can be calculated from the largest network size to the smallest, but it is best to subnet from smallest to largest. It's the breaking down of an IP address into subnets, multiple levels, and allocating it according to the individual need of each subnetwork. It is not supported by RIP version 1, but is supported by protocols such as OSPF, RIP version 2, and EIGRP. To understand VLSM, you should be very familiar with IP address structure. The best way of learning how to subnet a subnet VLSM is with examples. First, you look for the number of subnetworks and the required number of hosts per subnet. Here we see we have 3 routers, each with its own LAN, and it each has a backbone network to another router. In this case, the Class B address of 191.168.1.0/24 is allocated. The /24 means that this Class B address is no longer classful. Network requirements. The HQ router has a LAN that requires 50 hosts. Router 0 has a requirement for 14 hosts. Router 1 has a requirement for 30 hosts. And notice that we have 3 WAN serial backbone links with 2 hosts per network. A Class B address in its classful state allows for a total number of 65,534 hosts. This address is no longer classful. Subnet the IP address 191.168.1.0/24 to meet the requirements of this network. We will start with our backbone links as they are our smallest networks of 4 addresses each. Using the powers of 2 table, we need 2 hosts but 4 total addresses, so we count 2 places from the left. Apply it to our subnet mask, and our new subnet mask is 255.255.255.252. Remember that if you took the 252, subtract it from 256, it gives us a range of 4. That is our interval. We apply that, starting with the .0. There's our network ID, our host range, and our broadcast for our 3 subnetworks. Next, we will subnet for the R0 network of 14 hosts. So we count over 4 places from the left on the powers of 2 table, apply it to our subnet mask. The mask changed to 255.255.255.240. Here's our network ID, our host range, and our broadcast for our 1 network. We start with the .0. We cannot use it because we already used it for one of our backbone networks, but we still use it as a placeholder to start for our interval. Next, we will subnet for the R1 network of 30 hosts, so we'll count over 5 places from the left on the powers of 2 table. Apply it to our subnet mask. Our new subnet mask is 255.255.255.224. Subtract that to get our interval and our range of 32. Start with the .0. Even though it's in use, we can't use it for our network because it's already in use elsewhere on our network. Our network ID will be the 168.1.32. Our host range and our broadcast for that network. And finally, we will subnet for the HQ network of 50 hosts. We'll count over 6 places from the left on the powers of 2 table. Apply it to our subnet mask. Our new subnet mask is 255.255.255.192, giving us an increment range of 64. We start with the .0, can't use it, jump to 64, our host range, and our broadcast. and we still have the addresses from the 191.168.1.128 through 191.168.1.255 that we can use that are available for other subnets.